Iceoryx is like the central nervous system of any kind of autonomous machine or robot. So you have many sensors mounted on these new modern machines. They provide a lot of data to a central instance, which is like an algorithm which decides what to do, what to act, where to fly, where to drive, or what to grab. And this has to be done reliably and fast. And these are, let's say, the connections, the communication which iceoryx enables, like the nerves in our body, where our eyes sense, let's see, the things, the visual images which we see directly to the brain, and then we make a decision to grab a cup of coffee and drink it. The problem we want to solve with this project let's see, have multiple dimensions. The first thing is the technical side. This is a problem which any kind of machine has where you have a lot of sensors. If you are having a car with a lot of cameras, if you have a robot, a surgeon robot, for instance, also, let's say, which does some kind of delicate operations and so on, you need a nervous system which you can rely on. It's extremely important that when your camera detects an obstacle and then sends a signal to your emergency brake, that this signal arrives fast and reliably. If this is not guaranteed, you have a huge problem. For instance, when you're on a highway, you detect an obstacle and then the signal is lost. Well, this is the problem which we solve. The other thing is it must be solved fast. Let's assume again, you're on a highway and you send the signal, there's an obstacle, please do now an emergency brake, and it takes 2 or 3 seconds to perform this emergency brake because the communication is so extremely slow. This can be a difference between life and death, so therefore it has to be extremely fast. The other thing is also a social aspect. This is also why we founded Excite, is this project allows us also to work with other projects which are not like in our previous companies, projects where you can make a lot of money. They are like in science. We want to enable other people doing good things, like we have a project where you have a self-floating robot on the ocean collecting garbage. This is not something where you can earn big money, but it's a pleasure to be part of such a project and contribute to this. Or be in medical research where they require the newest state of the art because they want to, let's say, redefine for themselves the new state of the art. And if we now are in a big company and say, yes, but now we have to pay very expensive licenses and so on. And we have now as a company the ability to say, okay, we work together with big OEMs, they pay for innovation, and it allows also for us to have fun. And fun is defined really as working with companies or research on the cool new frontiers, where we are like childs in Star Trek and can explore the world. And this is like the personal motivation of many of us. Assume the following. You have in a school a blackboard. And now you want to communicate with your students. The next homework is due date until then, and you have the whole description of the homework process has to be done. Now you have two options. You take your pencil and the paper and write to every student individually, the whole homework is this, and the following things have to be done like this is the due date, and so on. And you have 20, 30 students, and you write this 20 or 30 times. It takes a long time. The better approach would be, you take the school blackboard, write it once, and give every student just a hint. Take a look at sheet number 4. This is your homework. This is exactly 0 copy. What we do is we write the data once and tell everyone who's interested in the data the place where to look, where to find information. And the big difference, for instance, with network protocols is they work like the teacher who writes the sheet over and over again, which is a necessity there for this technology. You cannot do it any other way, but if you're on the same computer, you have different mechanisms to work with. And this is something which we fully utilize. Experience we made when you have such a complex software you write, you fail, and at some points we failed on a technical side but also on a business side. When we were at Bosch, we were happy developers. We were really motivated by creating this open source. But the thing is, now that we have also created a company, you have to think about your business strategy. You have to finance this work. And in the beginning, we were developers and say, oh yeah, these business people, I don't want to talk to them. Now we are becoming these business people because we have to take some kind of responsibility how to finance this work. And then we realized, this is something also we had shown, I think in the first day in our talk, is that when you have defined your business case, and our business case is to say we have a core which is iceoryx, and then we can provide extensions where you can extend it so that, let's say, a car manufacturer can create, or let's say, deploy it on a car safely, so therefore it needs safety critical extensions. These safety critical extensions are like Lego building blocks, so therefore I need an adapter to just plug it in. If it's not there, it does not fit. And this is something where the business people tell us or define the strategy, and now the developer has to define an architecture to make it work. Where the business guy says, I want to have a plug-and-play system, and now the developer has to define an architecture to create such a plug-and-play system. And this is one of the major refactorings of iceoryx 2. And the other thing is, we wanted to make it absolutely safe. It's an extremely challenging topic, and what we achieved with classic iceoryx, like the special terms, it was safe but not yet secure in this sense. And we wanted to aim for zero trust, a completely decentralized system which can really be never destroyed in the ideal case. And this is something which we achieved with the refined architecture. Maybe the answer gets too long, but here the thing is, we have to appreciate what C++ has done, and that, for instance, a language like Rust would be not possible to deploy maybe in the beginning of the 90s because it takes a lot of resources, but provides a lot of things like memory safety, which is essential. And here the thing is, in the area where C came and then C++, it provided an additional improvement and made things safer, easier to develop. And at some point, C++ hit a barrier where it had to be changed so fundamentally that it would be a different language. And Rust filled right in this spot and said, okay, we have now problems which we can solve because our computers are faster. We can really analyze the code, detect memory leaks with our design patterns, or let's say our idioms and our rules, and with the help of the compiler. And this is something like a natural evolution, and this is something which we should take full advantage of it, because when you take a look at the numbers which Microsoft and Google published, where they said 70% of our bugs were memory safety problems which are completely gone with Rust. Now the thing is, you have a vendor for a web browser which says C++ is not secure enough for me. Now I'm an automotive guy, and now I have to argue, for the web browser guy, it's not safe enough. I'm creating a machine where people sit in and they rely that the brake runs really safely. Why do you not use Rust when others say it's not safe enough? And there are countless arguments, let's say for each side. The main problem is you have a lot of code which is already certified, but here we also want to bridge the gap that we say iceoryx, for instance, connects all of these words, that it's not an either or, but it's always an and. You can use the old word, the new word, you have a smooth migration path. And I would say we have to face Rust now. And also, I understand in automotive, especially projects which have a long lifetime, they will continue to write C and C++ code, and it will not go away. But if you write a new project, you should always consider Rust. And you need a very good reason why you stay with C++. SDV is there like a little Lego brick which solves one thing, like the central nervous system. It delivers data from A to B, and this is our fit in the end. We have other, let's say, projects which take care of how all these components are orchestrated, what their individual tasks are, if they detect an object, or maybe you have a fleet management system and so on. And when it comes to the nervous system, this is iceoryx.